Okay, so in a previous clip, we just looked at how the protons, neutrons, and electrons are arranged within an atom. But now we need to look at an example of how we work out how many of each of these species we have. So if we take an example using sodium as an example here, we can see that Na is given as the symbol for the element. So this identifies the element name, okay, by using the symbol. So Na for sodium, or S for sulfur, or O for oxygen, etc., etc. Sometimes you may see the name actually given underneath, depending on which type of periodic table you've got. And what we can then also see are two other numbers. Now, this bottom number is defined as the atomic number, or you may also see it as the proton number, which is a good clue immediately to see that within an atom of sodium, it's likely, and it is indeed true, that we have a number of protons and we have 11 of them, because it's defined as an atom of sodium which has 11 protons within it. If you change the number of protons within an atom, you change the identity of the atom. So, for example, if we were to add one more proton to this, we would stop it being sodium, and for example, we would create magnesium. Now, on the previous clip, we also suggested that protons are positively charged, and so that will give us 11 positive charges within the nucleus. And we know also that atoms are electrically neutral, which means that there has to be a corresponding number of protons, positive charges, balanced out by a corresponding number of negative charges. Those negative charges are given by electrons. And within an atom of sodium, and indeed within any atom, when it is in its neutral state, we have the same number of electrons as protons. So they're both defined by the proton number. However, we don't call the bottom number the electron number. It is by definition called the atomic or proton number. That then leaves us with the final number, which is the mass number of the atom. And again, in the previous clip, we suggested that the mass of a proton relatively is a unit 1 value, and the mass of a neutron is also unit 1 value. And we suggested that the electrons were essentially massless comparative to a proton and neutron. And what this allows us to do, because of those relative masses, is allows us to identify the fact that the mass number is the sum of the number of protons plus neutrons. So we take both of those species and add them together. Now, that's not telling us specifically how many of each of them there are directly. However, because we already know that there are 11 protons within here, and we therefore can work out the number of neutrons by knowing the number of protons and subtracting that away from the mass number, which will give us in this example 12 neutrons, and then obviously for an atom of sodium 11 electrons, and by definition the initial value of 11 protons. And in the next clip we'll look at how we arrange those, specifically looking at the electrons, whereby we will look more closely at the electronic structures of these species.